Okie dokie, welcome to problem number 1.56. We have 3 horizontal ropes pulling on a large stone stuck in the ground. So I'm guessing that's like right here, big rock. All right, producing the vector forces A, B, and C as shown. Find the magnitude and direction of a fourth force on the stone that will make the vector sum of the 4 forces 0. Okay, so the first thing that we want to do, let's take the existing 3 forces that we do have, and let's figure out what they're doing all together first. So what we need to do is break them up into their component form. So vector A is 100 newtons long at an angle of 30 degrees. So our x component is going to be adjacent, so that's going to be cosine. So we have 100 newtons cosine of 30 degrees in the x direction. That's pointing to the right, so that's going to be positive. And similarly in our y direction, that's the opposite of 30. So that's going to be 100 newtons sine of 30 degrees j hat, and that's pointing up, so that's going to be positive. Alrighty. So then let's look at vector B. We're just going to leave those in sine and cosine form for right now. Okay, so vector B, we have 80 newtons at 30 degrees from the y-axis. So our x component, our horizontal component, is going to be opposite of 30 degrees. So that's going to be sine 30 degrees. But now that's pointing to the left, so that's negative. Then our y component is adjacent, so that's going to be our 80 newtons cosine of 30 degrees j hat, and that's pointing up, so that's positive. And finally, C, let's just erase my scribbles on there. So C is at 53 degrees, so our x component is adjacent, so that's going to be our 40 newtons cosine of 53 degrees in the x direction. That's pointing left, so that's negative. And our y component is opposite, so that's 40 newtons sine 53 degrees j hat, and that's pointing down, so that's negative. Okie doke, so to figure out our vector sum, now we add our like components. Let's bust out our handy dandy calculator. We have 100 cosine 30 newtons minus 80 sine 30 newtons minus 40 cosine 53 newtons in the x direction. So adding all 3 of these terms up gives us 22.53 newtons. And in our y direction, we have 100 sine 30 newtons plus 80 cosine 30 newtons minus 40 sine 53 newtons for positive 87.34 newtons in j hat. Okay, so this is the net force that these 3 are all doing right now. So that's going to be a little bit to the right and a pretty decent amount upwards. So those are kind of like, whoa. So it's kind of like in that direction. is what these three are working together with. So we need a fourth force that's going to cancel that out. So let's call that D. So if this is what these are all doing right now, in order to get that to sum to 0, we want to directly cancel those out. So that means we want negative 22.53 newtons in the x direction and a negative 87.34 newtons in the y direction. So that when we add D, our fourth vector, onto these, we get 0 and 0. So this is going to be the vector notation of the force that we need to add to cancel these all out. So now let's find the magnitude and the direction. So the magnitude, we would just need to do our Pythagorean theorem. So take our 22.53 newtons squared and our 87.34 newtons squared. Punch that into our handy dandy calculator. U squared plus U squared plus. We get 90.2 newtons. Now I just copy pasted that from my calculator. So the exact number might be different. Let's see what the solutions say. 90.2. Cool. All right, sweet. We're golden. Rounding errors. Just want to make sure that they're not there. Okay, so that's the length. So this yellow one or orange one is what A plus B plus C is. D directly needs to cancel that out. So it's pointing this way with a negative 22.53 and a negative 87. So to find our direction, remember that our calculators can't tell the difference between this angle and this angle, but they're equal due to geometry, vertical angle rules. So the angle is going to be the inverse tangent of y over x. So that's going to be our minus 87.34 newtons over our minus 22.53 newtons. So the inverse tangent of that over that gives us an angle of 75.5 degrees. Now, that's measured from the negative x-axis. So we either need to specify below minus x-axis, or we need to add on 180 to get to the conventional measured from the positive x-axis for 255.5 degrees. And that's it.